Welcome back. Moving on to the first example, we're asked to find the horizontal and vertical components of a force that is 200 newtons acting at a 30-degree angle to the horizontal. So our overall force here, okay, is 200 newtons, and that's the magnitude of that force. The question says nothing about direction other than the 30-degree angle, so we don't know if this is northeast, southwest, or what, so we can only assume magnitude at this point. So we're going to start by finding the horizontal, and we're going to remember from the previous video this formula we have here. So the horizontal component is going to be the magnitude of F subscript x is, well, we know the magnitude of F is 200 newtons, and that is multiplied by the cosine of 30 degrees. And hopefully you know your special triangles, or tangent hand in this case, and the cosine of 30 degrees as an exact value is actually root 3 over 2. So we have the 2 knocks the 200 off to be 100, and we have a final answer of 100 times root 3 newtons. So this is the amount of force that we have acting in exactly the horizontal direction. Now we also need to find the force acting in the vertical direction. I'll ask you to pause the video now and try this on your own, and after you resume, I'll have the answer for you. So pause now, please. So hopefully you got 100 newtons here. So we're doing the overall force times the sine of the 30-degree angle, and the sine of 30 as an exact value is 1/2. Again, you get that with special triangles or with tangent hand, and 200 times 1/2, so you get 100 newtons in the vertical direction. Moving on to example 2, it says that we have two forces. They're acting on an object. One force is acting 7 newtons in the east. The other is 12 newtons in the west. We need to find the resultant force. Remember, the resultant is the addition of these two forces. So the first thing I'm going to do is I'm going to make an assumption. So we have a northeast southwest grid here. I'm going to make the assumption that east is positive and west is negative. Okay? You can make the opposite assumption when you start the question, and your answer will be exactly opposite of mine. That's fine, because as long as you tell the reader what your assumption was before you start. So I'm going to say assume that east is positive. So again, as long as you make this assumption, then the rest of your question becomes valid. So knowing this, we have a vector that goes 7 newtons towards the east, and we have a vector that goes 12 newtons west. So sorry, this was east, this was west. And we want to know the overall result. Well, the resultant vector is actually just the addition of vectors. It's the overall vector sum. So we just want to add these two vectors together. Well, knowing that east is the positive direction, our first force is going to be positive 7 newtons. And now our second force, because west is considered negative, this is actually negative 12 newtons. And if we do 7 plus negative 12, we're going to end up with negative 5 newtons as our overall resultant force. Or you could say it with direction. You could say it's 5 newtons in the direction of the west. So either conclusion is fine for the overall resultant vector. Please see the next video for the following